All right, so welcome to week 32. Doing things a tiny bit differently. Just as a reminder, all your notes are going to be available starting at the beginning of the week so that you can work through it at your own pace. But you're still going to have to take your daily check-in so I can measure your mastery and take attendance. So this lesson on arithmetic sequences is recommended for Tuesday, and you'll start seeing this topic on the check-in then on Wednesday. So remember, you can pause and rewind as needed for this video. You've got the option for closed captioning or subtitles if that's going to be helpful to you. So let's get started. So the first thing I want to do is talk a little bit about vocabulary here. We've got sequence. Now a sequence is just an ordered set of numbers. So a sequence some of you might recognize is the Fibonacci sequence. And the idea here is that they are in a very particular order. We've got the first number, and it has to go first. The second number, it has to go second. In the Fibonacci sequence, the next number is always the sum of the two before it. So this one has to come in this order. Then 3 for as the fourth term, 5 as the fifth, as the next term, and so on. So like order matters in a sequence. Now, some sequences have special characteristics. One of those is the arithmetic sequence, which means that consecutive terms have always had the same term added or subtracted. So when I say that, looking at this example that we have here, 2, 5, 8, 11, 14, it's arithmetic because each time we're adding 3, and it's constant, it's consistent. Each time we're just adding 3. That makes this an arithmetic sequence. So the first thing we want you to be able to do is to look here, determine if the following sequences are arithmetic. If so, find the common difference. So the way that we tell if they're arithmetic is the question is, does this common difference here, right? That's what that term means. We're talking about, in this case, the plus 3. Does that exist? So you can look here and ask yourself, what amount is being added each time? Well, 6 to 8 is plus 2. 8 to 12, oh, that's plus 4. So you can see here, this is not the same. It is not in common. So this is not arithmetic. And you actually don't have to keep going. Once you find 2 that are different, obviously check your work, but once you find 2 that are different, that's enough to prove that it's not arithmetic. So in this case, the number that would need to go from 13 to 8 is going to be a negative because we're going down, we're decreasing, and that would be minus 5. 8 to 3 is also minus 5, looking promising. So you'll notice that these are all constant. They are all the same. This is a common difference. So yes, it is arithmetic. And the common difference, which we're going to use D to stand for, is negative 5. So here we've got 2 different examples of sequences. They're both sequences, but only B is arithmetic. Now, even though we are starting chapter 12 here, we are still going to be using some of our graphing ideas. And so we're going to talk about the function of an arithmetic sequence. Now, remember, function is an equation with 2 variables. We've seen it a couple times before. Now, there's a couple ways that people write functions of sequences. The first way is the kind of intuitive way as a mathematician, but it looks very weird to young students. So I'm going to show you both. So this is the first one. It doesn't look like any function you've seen before, and that's all right. So let's define what all these terms mean. So remember, arithmetic sequences are where a common difference gets added each time. So what this side means is that our first term, that's what this sub 1 means, just like we've used for like slope. This is our first term, and every time it's being added by the common difference, which we hopefully recognize from before, and you're adding that and then the question is, how many times are you adding that common difference? Well, you're adding that n minus 1 times, because for each term, you're going to just add it, you started with 0 of them, so then if I wanted to get to the 10th term, let's say n equals 10, n is the number of terms, you would add 9 common differences to the first one to get to that 10th term. So this is the way a lot of mathematicians will use this formula, but the kind of cool thing that we can do is we can do a little bit of arithmetic and algebra with it. We can distribute here, and we can then get that our next term, our nth term, sometimes it's called, you can just say n is next if that helps you remember, is the first term plus dn minus d with the distribution. And so then this is sort of the tricky logical thing, is that if I have the first term and I took away a common difference, this would create sort of what happens 0, so before any terms are written, plus dn. And this is a lovely slope-intercept form, because here's here's what's happening at 0, and then we have our variable that's changing things here. We're used to seeing it with x, but it's the same idea of what's happening at the beginning and there, and we're looking at something that's just in slope-intercept form, where x is the term that you're looking for. So this can be a nice helpful tie-in. So then if I'm looking at question number 2, given the sequence f of x is equal to 3x minus 2, we can see that this is an arithmetic sequence where 3 is in the position of D down here, and then negative 2 is that initial point, right, which we think of as also, we can think of this as slope and as the first term. And so this just tells us kind of what the slope would look like. And if we graph this, starting at negative 2, and then slope of 3, so up 3 over 1 to this point here. Whoop, I have this writing. And we can plot out a few more. So we've got these points that we plotted using slope-intercept form, and with our x values down here, we can then see, oh, here is our first term, because it goes with x. So this is our first term, which we write as a sub 1. Here's our second term, because it goes with x equals 2. Here's our second term, our third term. So even if we're looking at a graph, now we can write out our sequence, if you're interested in, because our sequence then is 1, right here. Our next one is up 3 higher, so 1, 2, 3, 4 is where our second term is. The third one is at 7, and then the fourth one is at 10. So there's our sequence right there, and if we would like, we can then draw in the line of the graph. So here we're sort of doing the opposite, where we have the sequence and we're asked to write the formula of its function. So I'm going to be using this initial one here, where remember that a sub n is, you can call it the nth term, but if it's helpful, just think of it as the next term. And then a sub 1 is our first term. And then d is our common difference. So here, the first term is always easy to find, which is the first one. So this says that a sub 1 is 3, and the common difference, we just look between two terms. 7 to 11 is plus 4, and it's always nice to just check, make sure it's plus 4 on the other sets as well, which it is. And that plus 4 is our d. So d is equal to positive 4, a sub 1 is equal to 3. and we can just then plug that in where we need to over here. So the next term, we don't know that one, but the first term is 3 plus 4n minus 1, and it makes sense that this is a function because we have two unknowns and they're different, two different variables, and it's in an equation. You can leave it like this, but you'll often find it simplified using the distributive property here, and then the like terms combined. And that's a fine equation. You can leave it just like this. If you want it to look more like the equations you're used to in terms of x's and y's, you can just replace that first term, y is equal to 4x minus 1, like that. Both ways are just fine. You're just using different variables. Now, in number 4, it says, given the sequence above, find the 30th term. And this is what's great about a formula, is that you could have just kept going plus 4, plus 4, plus 4, all the way out to 30, but that seems like a lot. And if you've got the time, can't argue that you do at this point. That's just fine. But we can use maybe our time a bit better than that. So if I have my formula, n, remember, is the term. So if I want the 30th term, that just means replace n with 30. Everything else stays the same. Keep the times 4, the minus 1, and from there it's just a little bit of algebra and arithmetic to say 4 times 30 is 120, minus 1 still, which is 119. So you could have just written all those out all the way, but this way's a lot faster. So if you're working ahead, remember that this topic will show up on the check-in on Wednesday of this week. Put any comments or questions that you have so I can check onto that, and have a wonderful day. I will talk to you later.